Hello.
Hello, sir.
Yeah. Hi.
Hello, sir.
Hi. We'll be doing problems for functions. Uh, have you seen that book, the Samir Bansal textbook, problem book?
Yeah, the one we would.
Yeah.
Yeah, I tried a few questions.
So what happened?
The starting one, so I didn't like. I tried till up to 20 questions, so I didn't really face any problem in the first 20.
First
So
20.
yeah, like it took me a lot. Like it took me time to solve each question, but it wasn't like I couldn't solve it.
Okay. Uh,
And apart from that, I couldn't do more because like we had a test also yesterday, so I was preparing for that as well.
okay. Anybody else has any problems and all in this?
Start from this.
I
I
didn't
actually
really.
finished the previous one.
What?
I
What?
just read the theory for this
Uh,
Yeah,
theory
because I
for
was doing
where?
the problems that we gave. Like before, you had sent a PDF, that Fiji whatever.
Yeah. Yeah.
Yeah,
So
I finished that mostly, and then I
okay.
started reading this.
Okay. Fine. So let's do some questions from this level 1 only. Question number 21 onwards. Uh, you have the PDFs, no? Everyone has the PDF, right?
yeah.
So, level 1, question 21. Number of integral values of x. Number of integral values of x satisfying the equation, satisfying signum SGN, signum of 15 by 1 plus x square. 1 plus x square is equal to GIF of 1 plus 2. Okay, there's a fractional part also, 2x. Okay, is what? Number of integral values of x which satisfy this. So, first of all, you need to know what is signum function, which we have discussed, I think.
Yeah.
Signum of x is basically 1 if x is greater than 0, 0 if x is 0, and minus 1 if x is less than 0. So, right now, okay, so right now think about this one. There is a GIF here. The square bracket is a GIF. So that's fine. But the thing is that you have to decide whether this is 0 or 1. You know that 15 by 1 plus x square will always be positive.
Positive, yeah.
So all you have to decide is whether it is 0 or whether it is some positive thing.
Positive, yeah.
Correct?
Yeah.
So, okay. So in case 1 plus x square is greater than, okay, 1 plus x square is greater than 15 if it is true, right? Then what happens is this is a fraction, right?
Yeah, yeah.
Then that is GIF of that is 0, right?
0, yeah,
Right.
yeah.
Yeah.
GIF of that becomes 0 then. Okay. So then signum of 0 is 0, right?
Yes. Yeah.
Yeah.
So this is one case where this side is 0 and this side is this thing, right?
Yeah. Right.
If the second case is 1 plus x square is less than 15, right? And basically this means x square is less than 14.
Yeah.
Right?
Yeah.
X square is less than 14. There could be x square values can go from 0 to 14. The values will be dependent on that, right? This signum thing. This GIF value will depend on that, but it is positive, so it will always be 1, right?
Yeah.
Yeah. Yeah.
Right.
The GIF will change depending on x, but it is going to be
It is going to
positive.
be positive.
Positive. Yes. Yeah.
So it is always be 1.
Anyway,
So
one,
1
yeah.
is equal to this. That is the second case. So you have to think about how you can solve this. How many integral values will satisfy basically. So let's think about the top equation first. So there is a GIF, and inside a GIF there is 1 plus something. So when an integer is inside, you can take the integer out,
Right.
right? So this is 1 plus, this is also like this, fractional part of 2x, right?
Mm. Yeah.
So now notice that this is the case when x square is greater than 14, right? So x is positive here. No, not necessarily. X could be negative also. Okay. Fine. So you have to think of situations where this thing is -1, right?
Yeah.
GIF
Yeah.
of 2x is equal to -1.
-1.
So, okay, so that means that this fractional part should be between -2 and -1, right?
Right. Yeah.
Correct. So, okay, fine. And fractional part of x can be written as 2x minus GIF of 2x, right? Correct.
Yeah.
But maybe that will not help. So we have to think about it. Fractional part of 2x. So is between -2 to -1, right?
Hmm.
Uh, let's think about that.
Wait.
Fractional part of
You're
2x.
using GIF on 2x equal to -1 to come 2x is in between -1 and 0.
-1 and 0. Oh, yeah. Yeah.
Yeah, so greater than equal to -1 and less than 0.
Hmm. -1 and 0. Yeah. Not equal to 0.
Not equal to 0, equal to -1.
Hmm. So this is the situation. Okay. So the whole thing is between 0 and -1. That means fractional part of something is between 0 and -1. But fractional part of anything has to be between 0 and -1, right? Or between 0 and 1.
Yeah.
If
Yeah.
that thing is negative, it has to be between 0 and -1.
Right.
So basically, this implies that 2x is negative, right?
Yeah, yeah.
2x is negative, and think about this. I feel like there is no case in which this happens, because anyway x has to be an integer, no?
Yeah. Yeah.
If x has to be an integer, the fractional part 2x will be an integer, so fractional part of something will be 0, right?
Hmm.
Oh yeah, actually you have to think of this thing.
Integer, yeah.
So if you are searching for integer values of x, then 2x is also an integer and fractional part is always 0.
Yeah,
Yeah.
yeah.
So the first inequality can never be true because you have 0 is equal to 1. So there is no case here. This is always true, right?
Hmm. Yeah.
Always true, because now you have 1 is equal to 1, right?
Yeah,
So all integers such that x square is less than 14, right?
yeah, yeah.
So let's look at the integer 0, plus minus 1, plus minus
Plus
2,
-2, plus
plus minus 3, these
Yeah,
integers, right?
yeah.
These are the integers for which x square is less than 14. So these are 7 total.
Yeah. Yeah.
7 integral values are there,
Yeah.
right? So actually you have to focus on this part of the question to finally solve it.
So,
Integral values of x, so fractional part will be 0.
Yeah.
yeah, yeah.
Okay. Question 22, let's look at. Function is defined fx. Fx is equal to sine to the power 23x minus cos to the power 22x, and gx is equal to 1 plus half tan inverse mod x then the number of values of x, then the number of values of x in the interval minus 10 pi to 20 pi, satisfying the equation fx is equal to signum function of g of x. Fx is equal to signum function of g of x. You have to find the solution to this. Is how many such solutions are there, right?
Yeah.
X has to be between minus 10 pi to 20 pi. Okay. So okay, let's think about this. Let's think about gx because we have to do signum function of gx, correct?
Right.
So gx is 1 plus half tan inverse mod x, right? So the tan inverse function, tan inverse x function, when is it defined? It takes domain of this is minus pi by 2 to pi by 2, right?
Okay. Yeah.
Yeah.
And range of it is minus infinity to infinity,
Yeah.
right? So now domain means input to this is should be, actually I'm wrong, I think. Range is minus pi by 2 to pi by 2, domain is in,
And inverse.
right?
Yeah.
This is the
yeah,
domain.
Yeah.
This is domain and this is range.
Yeah.
Okay. So domain can be anything basically to this.
Hmm.
But here in this function, you are going to give x between this to this, right?
Yeah.
Yeah.
And if you give x to between this to this, finally you have to take a mod x, right?
Yeah. Yeah.
Yeah.
X will turn out, the mod x input actually will turn out to be a positive input, right?
Hmm.
Tan inverse something positive, right?
Something positive. Yeah.
Tan inverse something positive will be something positive because 0 to pi by 2 will be the answer then,
Yeah.
right?
Yeah.
Because minus pi by 2 to 0 comes when you give something negative to it,
Yeah. Got it.
right? Because tan 0 is 0, tan infinity, tan pi by 2 is infinity. So 0 to infinity, values are attained in 0 to pi by 2 range, right?
Yeah. Yeah.
So tan inverse of something positive will be something positive.
Positive.
I don't care what it is as long as it is positive because it is 1 plus positive, right?
Yeah.
So gx is greater than 0 we are getting, right? So signum
yeah.
of gfx will be 1.
Yeah.
So this understanding you have to have, only then you will be able to get a simple equation. Now you have to solve just this equation, right? Sine
Yeah.
to the power 23x minus cos to the power 22x is equal to 1,
1.
right?
Yeah.
Now write this as sine 23x is equal to 1 plus cos 22x, right?
Right.
Yeah.
Now this can never be true unless this is 0 and this is 1, right?
Yeah.
Correct.
Sine cannot be greater than 1, right?
Yeah.
Yeah. Yeah.
So sin x must be 1 and at that moment cos x will be 0, right?
0. Yeah.
Correct.
Right.
So
Yeah.
sin x is equal to 1 means x is equal to n pi plus minus 1 to the power n into pi by 2, right?
Right. Right.
Correct. So this is the general solution, right? So
Yeah.
you have n is 0, you will get pi by 2, n is 1, you will get pi by 2 again, n is 2, you will get 2 pi minus 2 pi plus pi by 2, right?
Yeah. Yeah.
Yeah.
And so on. So we have to search for all the solutions that lie between all of these values. You will realize that this will becoming 0.
Yeah. Yeah.
Cos is becoming 0 at all of those values. So you have to get solutions such that minus 10 pi is less than equal to this n pi plus minus 1 to the power n pi by 2, right?
Yeah.
Less
Yeah.
than equal to 20 pi. You have to count total number of how many such solutions are there, right?
Yeah.
So let's just take some values 0 and 1. Both give answer here is pi by 2, right?
Yeah.
Correct. And 2 gives 2 pi plus pi by 2 and 3 gives 3 pi minus pi by 2, right?
Yeah. Yeah.
Which is the same thing, right? Which is 5 pi by 2, right? 2 and 3 gives the same thing. 4 and 5 will give similarly same thing. 4 pi plus pi by 2. So 4.5 pi, right?
Yeah.
Or 5
9
pi
pi by
minus
2.
pi by 2, right?
Yeah.
4.55 pi, and then 6 and 7 will give 6 pi 6 pi plus pi by 2.
Just add 4 pi.
So that will become, this was 2.5 pi, right?
Yeah.
This was 0.5 pi, so it will be 6.5 pi, right?
6.5. Yeah.
And
Yeah.
similarly, it will be 8.5 pi. You have to go up till 20 pi, right?
Yeah.
Right. Yeah.
So it will be 18.5 pi, right? Finally,
Right.
Yes. Yeah.
Yeah.
right? So how many are there? Like how many are there till then? 18 will come, and n is equal to 18, right? Right? 18, 19.
18, 19. Yeah.
Yeah.
So 0, 0, 2, 4 till 18, right?
Yeah.
These are the positive ones, right?
Yeah.
Correct. So this is basically how many? 2 into 1, 2 into 9. So 9 from here to here and 1 from here, 10, right?
Yeah.
Yeah.
10.
10 roots here, and we have to go before also, right? So minus 1 if you put, what comes? Minus pi plus minus 1 to the power minus 1, so minus pi by 2, minus 1.5 pi, right?
Yeah.
Basically subtract 2 pi na, from here.
Yeah.
Yeah. Yeah. Yeah.
So you'll get minus 1.5 pi, minus 3.5 pi, minus 5.5 pi, minus 7.5 pi, minus
minus
9.5 pi.
9.5. Yeah.
1, 2, 3, 4, 5. 5 roots there. In the negative side, 5 roots. In the positive side, 10 roots, right?
Yeah.
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 Total number of values of x is 15.
15.
Yeah.
So first of all, the question is about understanding this part and why signum of g of x is 1, right?
Right.
Once you got that, it became a trigonometric equation, finding how many roots will come.
Yeah.
And this
Yeah.
equation also is not a normal equation. You have to solve it by thinking about the extreme values of sine and cos. Like you would have seen questions like this where one side cannot be less than 1 and stuff like that. So this is, you cannot really solve it normally. You have to solve it by thinking about what are the possible values, right?
Yeah. Yeah.
Maximum value of sine 23x, sine power 23x, and maximum value of this, right?
Yeah. Yeah.
So once you get that, then after that, you have to count the solutions, right?
Yeah. Yeah. Got it.
Okay. 23, let's look at. You have to find the maximum value of the function fx is equal to x power 4 minus x square divided by x power 6 plus 2x cube minus 1, where x is greater than 1. Okay, so try to find this. You two guys try first. I will do it later. Find the maximum value of this function. So there are actually two ways to solve this. One is by calculus. The other way is by
Yeah, you can
algebra.
find it by differentiation.
Differentiation will be quite long.
Differentiation will be quite annoying, I think. So try the algebra way. Calculus method will be a little annoying because of the differentiation.
Yeah, the differentiation is huge.
Calculus way, you'll get stuck at this point. Now you have to factorize and solve some roots, find some roots. So
Yeah, calculus, I'm not getting it.
finding roots of this is hard. You have to guess some factors and all. So it might not be easy right now. Guessing any factors of this Yeah, I don't think you should do it like this. So think of some other alternative way.
Yeah.
Fx is equal to x power 4 minus x square by x6 plus 2x cube minus 1. So one thing you can do is divide by x cube up and down, because that will make the top part x minus 1 by x, and
Yeah.
denominator is becoming x cube plus 2 minus 1 by x
One
cube.
by
So you can do some simplifications now. X minus 1 by x is on top, and denominator has x cube minus 1 by x cube
whole
plus 2. So x cube minus 1 by x cube, you can know this identity.
x minus 1 by x whole cube plus
This identity, you know, 3 times x minus 1 by x, right?
yeah.
So therefore, this part can be written as x minus 1 by x whole cube plus 3 times x minus 1 by x, right?
Plus 2.
Plus 2, huh? There we'll write it. So fx is equal to, you're getting x minus 1 by x divided by x minus 1 by x whole cube plus 3 times x minus 1 by x plus 2. Okay. Fine. Now you have to think
Now
of
you
how
can
to
put
find
x minus
maximum
1
and
by
all.
x of t or something. And do d by that.
You can do
Yeah,
that.
you can
Simpler.
substitute it.
Yeah.
You can do that. T by t cube plus 3t plus 2, right? F of t. And then again, you can do calculus, but you can also do one thing where you don't do calculus at all. X minus 1 by x, and if you take x minus 1 by x whole cube plus 1 plus 1 plus 3 x minus 1 by x, right? This part, what we can do here is we can do AMGM on this part. These three terms, okay? So how will we do AMGM? We know that AM of these three terms should be greater than the GM.
Yeah.
So if I say x minus 1 by x whole cube plus 1 by 3 is greater than equal to cube root of x minus 1 by x whole cube into 1, right?
Yeah.
So this part is equal to simply x minus 1 by x, right? So you have x minus 1 by x whole cube plus 2 is greater than equal to 3 times x minus 1 by x.
Yeah.
Right?
Yeah. Yeah.
So this part is greater than that, right?
Yeah.
So if I substitute, so basically this means this is lesser than this, right?
Yeah.
So if I put something lesser in the denominator, the
Yeah,
function is
then
greater
it
than
becomes
that,
one. Yeah.
right? Function is always greater than equal to x minus 1 by x divided by, instead of this, I'll put 3 times this, and this is added to 3 times this. So 6 times x minus 1 by x,
1 by 6.
1 by 6. Function is always greater than 1 by 6. The reason we chose these three terms as AMGM was because numerator had that, and I needed that somehow coming again.
Oh,
Yeah.
yeah. Yeah. Yeah.
If I take these three terms, you get 3 times x minus 1 by x, and this gets added and it gets cancelled. If you took any other terms, it will not get, first of all, it will not come out very nicely out of the root, right?
Yeah.
Yeah. Yeah.
If you have to take it out of the root, you have to have a cubic thing and a cube root. So 3 terms you need. But if
Yeah.
you have any term involving this, then it will not work, right?
Yeah.
Right. Yeah.
1, 2, 3, and you could also do 6th root, I think. You could do 6th root of the whole thing. Separate it out into 6 terms, right?
Right.
You understand what I'm saying? This is one term. 3 terms from here, x minus 1 by x, x minus 1 by x, x minus 1 by x, and 2 terms from here, 1 and 1.
Yeah.
You can say
Yeah.
AMGM of 6 terms, right?
Yeah.
And that will be 6th root, and 3 terms here and 3 powers here will become 6th power, right?
Yeah. Yeah.
Yeah.
That will also work. So overall AMGM on the whole thing will also work if you split
Yeah.
it properly. Then also you will get 1 by 6. Okay.
Yeah. Even with calculus, yes.
At this point you could probably do
Yeah.
calculus also,
Yeah.
but
Coming 1%.
this will be faster.
Yeah.
Okay. So that is this maxima minima question. Now next one is, okay, so some equation is there. Question 24. Sum of all positive integral values of A, positive integral values of A, values of A. You have to find sum of all positive integral values of A, where A belongs to 1 to 500, for which equation GIF whole cube plus x minus A is equal to 0 has a solution. So you have to search for those values of A for which this equation has a solution and add up all those positive integral values of A.
Yeah. Yeah.
Okay. Fine. Okay, think about it.
Do we write the greatest integer function as x minus fractional part of x and then take the cube and solve it?
Fractional part of X is always more complicated than GIF. You should never replace fractional part of X. The greatest integer function as fractional part of X.
Oh, okay.
Thinking about fractional part is much harder than thinking about GIF. Don't make a GIF question into a fractional part question.
Yeah, okay.
You have X is equal to what? X is equal to A minus GIF of X whole cube. Right?
Yeah.
If you are searching for integral values of A is an integer. And this is also an integer. So therefore it implies X is an integer.
Right.
If you are looking for integral values of A, then this is an integer, this is an integer. So X must be an integer.
Yeah.
If X is an integer, then the question is very simple because GI of X is X cube only.
Right. So it can go from 1 to 7.
So A is equal to X plus X cube.
Yeah.
Yeah.
Where X can go from 1 to 7, correct?
Right. Yeah.
So A values are such that X can go from 1 to 7, and just add up all the A values, right? You have to add up all A values. So basically, you have to get summation of A, right?
Yeah.
Yeah.
So do summation of A here, 1 to 7, right?
Right.
Like A could be, X could be 1, X could be 2, X could be 7, X cannot be 8, right?
It
Yeah.
cannot be.
Yeah.
Yeah.
So then just add up all of these X's, right? All of the A's, right? So that is
Yeah.
fairly simple. 7 into 8 by 2 plus 7 into 8 by 2 whole square, right? N into n plus 1 by 2 whole square is this cube summation. No?
Yeah.
So this will be equal to 28 plus 784.
812. Yeah.
So that is the answer. Are you understanding?
Yes, sir.
Yeah.
Yeah.
Key trick is to realize that X is an integer.
Yeah.
Because you can rearrange this equation, because you know that A has to be integer, that's why X has to be integer. And if X is an integer, then equation is just simply X cube plus X minus A equal to 0. Right?
Right.
Yes,
Right.
yeah.
Yeah.
Okay. The next one, function is defined and you have to find whether it is 1, 1, 1, 2 and stuff. Okay. F is defined from R to R, and Fx is given as half ln root over x square plus 1 plus x plus
Right.
root over x square plus 1 minus x. Okay, you have to decide 1, 1 on 2 for this, and in question 26 you have to find the range. So try 25 and 26 both yourself. Okay, we'll discuss it. I'll be back in 5 minutes. Try 25 and 26. Okay. This function. So what you have to decide is 1, 1 on 2.
It's not 1, 1 because if you just put fx minus x,
If you put f
You'll
of
get
minus x, what is coming?
you get same thing f of x because x square will stay the
Ah,
same.
uh-huh.
Yeah, yeah.
One side will come
Same.
minus x, other side minus x.
Okay, so it is even function.
Yeah.
So it cannot be 1, 1, obviously. Right?
Yeah.
Cannot be 1, 1. Then that is decided. So now you have to decide on 2. On 2 means you have to check range and check
Range,
codomain. Codomain is real numbers.
Yeah.
You have to check whether range is, so range is real numbers also. So think about this range, right? Okay. So ln function is there. Ln type of, okay, ln can potentially be all, it can take all values, right? There is the potential, but here is it taking all values, you have to decide. So okay, so this part,
It's coming always positive.
this part is always positive, I think.
Yeah.
Yeah, yeah.
Always greater than 1. And then ln will always be greater than 0.
So 1 second, is it always greater than 1? This part, that might not be true. Wait, is it always greater than 1?
X square plus 1 is always greater than x. Root of x square plus 1.
This is,
Yeah.
Always greater than x.
so this one will be, okay, let's just check this. Root of x square plus 1 plus x plus root of x square plus 1 minus x minus 1, right? If this thing is positive, then this is greater than 1, right?
Yeah.
If this is greater than 1, ln will always be positive, right?
Yeah.
So, okay, so let's just check this. For this, let's say this is equal to s, let's square it, s square, right? It will become root of x square plus 1 plus x plus root of x square plus 1 minus x plus 1 plus 2 times root of this into this, right? That will be x square plus 1 minus x square, right?
Yeah.
Minus 2 times root of this one with this and minus 2 times root of this one with this, right? Correct. It is a plus b plus c whole square. So there are
You get
3.
more terms in the first multiplication as well.
What?
More terms in the first multiplication.
No, I'm saying a square is this, b square is this, c square is this.
Oh, but
2,
sir, why did you put the -1 in that equation?
I put minus 1 because I have to decide whether this is
So it's
greater than
greater
1
than
or not,
Oh, like that. Okay, okay.
whether this is positive or not. So that's why I put minus 1 and I'm getting 2ab term here, 2 minus 2bc minus 2ca, right?
Yeah, so AB will be.
No, it's correct.
Okay, yeah. Correct.
This is correct only.
Yeah.
You're getting this plus 2 plus 1. Okay, you're getting s square is equal to 2 times root over x square plus 1 plus 3, right? 2 from here and 1 here minus 2 times s.
Yeah.
This is 2 times s, right? So okay, we know that this part is greater than equal to 5, right?
Yeah.
So you have s square plus 2s is greater than equal to 5, right? Correct. So you have a quadratic s square plus 2s minus 5 is greater than equal to 0, right?
Yeah.
When x is 0, it is equal to 5, right?
Right.
Correct. When x is 0, it is equal to 5. So let's forget about that 0 part, because if you put x is equal to 0, this is coming positive, greater than 1, right? It's coming 2, right?
Yeah, 2.
So let's not worry about the x is equal to 0 part, so we can remove this. Let's think of when this is true, right? So you have, when will this quadratic be positive? This quadratic will be positive. This is b square minus 4ac, which is positive. So this quadratic will be positive when it is beyond the roots, right?
Right, yeah.
S value has to be beyond the root. So minus 2 plus minus root over b square minus 4ac. What is b square? 4 minus minus plus 4, 24, right?
24.
By 2,
Yeah.
right? So minus 1 plus minus 2 root 6, so root 6, right?
Mm-hmm.
Correct. So this is minus 1 plus root 6, and this is minus 1 minus root 6, right?
Yeah.
So this inequality is true when s is greater than root 6 minus 1, or s
Yeah.
is less than minus root 6 minus 1,
Yeah.
right?
Yeah.
That
Yeah,
time,
right.
that time you have this s square plus 2s is greater than 5, right? But we had to decide whether s is greater than 0 or not, right? S is greater than 0 or not. Okay, so let me think 1 second. S plus 2.
Or can we just try putting some values for x and then checking in the equation?
Putting some values of x and checking.
Yeah, that'll
But
give
that
us.
might not.
No, we have to decide greater than 1. No, how will we check values and say greater than 1 or not?
Hmm.
It's not positive, it's always positive, that is guaranteed.
Yeah.
But greater than 1 is right now not seeming to be guaranteed. Let me think, what can we do? Hmm. This half can we use somehow? Half means you have to put half here, right?
Yeah.
But that will make it more complicated. Okay. It doesn't seem like it will be less than 1, but right now there is no proof.
Okay, yeah.
This is okay. What if we do AMGM? Okay, AMGM we can do in these two terms.
Okay.
We can say this square plus 1 plus x plus root over x square plus 1 minus x by 2 is greater than equal to root of product of these two, right? So that will be x square plus 1 minus x square. Oh, okay, we are getting greater than 2. This thing is greater than 2, we are getting, right?
Yeah.
Each of these quantities are positive, right?
Yeah.
So you can apply AMGM, and when you do AMGM, you get greater than 2, right?
Yeah.
So now this is a proof that the input to the ln, right, half ln something, this part is greater than 2.
Yeah.
Then obviously ln cannot take minus infinity and all those negative
Yeah.
values, right?
Hmm.
This had to be less than 1 to take negative values.
Yeah.
So it is not onto and it is neither 1, 1.
Neither one.
So the answer will be neither 1, 1 nor on 2. Okay.
Yeah.
So AMGM you can use. So right now we should have used AMGM in the beginning only,
Hmm.
instead of trying to simplify it and all. The reason it worked is because these were nicely there in terms of products were nice. No, product of these were
Yeah.
nice because they're conjugate type of terms.
Yeah.
Mhm.
Yeah.
Okay. Question number 26. You have to find fx is given and you have to find range of fx. Fx is 4x x square plus 1 by x square plus 1 whole square. This is obvious. Now that we have just done AMGM, that is obvious, no? This. Just do AMGM on the denominator. Right?
Yeah. Hmm.
Yeah.
So you're getting x square plus 1 whole square is greater than equal to 2x x square plus 1,
Yeah.
right?
Yeah.
So 2x x square plus 1 is lesser than this, right? So fx will be greater than 4x x square plus 1 by 2x
By
x
2x
square.
x square plus 1.
So greater than equal to 2.
Yeah.
So you're getting fx is greater than equal to 2 immediately, right?
Yeah.
So only option that satisfies that is D, but
Yeah.
let's worry about the maxima also. Let's think about the maximum part also. Wait, have we made some mistake here? Answer is what? Answer is saying something else. 1 second. Answer is saying B. So we have to check once what is going on. We can apply AMGM because both quantities are positive. So we have this inequality for sure. So greater than 2x x square plus 1. This is greater than 2x x square plus 1. So 2 times this is greater than 4x. So 4x is less than equal to 2 times this. Basically, you have 2 times this is 4 times this, right?
Yeah.
Yeah.
So we can say 4x x square plus 1 is less than equal to 2 times this, right?
Right.
Oh, so we are getting actually less than equal to 2, no? Maybe I have put it wrongly here. I think we are getting fx is less than equal to 2 from AMG. Think about what I have done. This should be 4x, right?
Yeah.
4x x square plus 1 is less than equal to this, right? So
Yeah. Yeah.
in the function itself, you can write fx is less than equal to 2 times x square plus 1 whole square divided by x square plus 1 whole square. You're getting fx is less than equal to 2,
Less than equal.
right?
Hmm.
Okay. So that doesn't solve it for us, but it gives us a thing that above 2 it cannot be. So D is wrong, we are getting, right?
Yeah.
Okay. So let's think of some other way then. We have to think of some alternates now. Okay. Fx is equal to 4x x square plus 1 by x square plus 1 whole square. Uh, okay, what if we divide up and down by x square? Let's see what happens. X square, if we divide, we get here 4x plus 1 by x, right?
Yeah.
1 plus x plus 1 by x whole square, right?
Yeah.
Okay, so now we can take x plus 1 by x as t. So this is 4t by 1 plus t square, right?
Yeah. Yeah.
And now you can do calculus, or you can do whatever
Calculation.
you want, right? So
Yeah, and then it's fine.
so we have t is greater than equal to 2, by the way, for x greater than equal to 0, right?
Hmm.
Because x plus 1 by x will be greater than 2 if x is positive, right?
Yeah.
Yeah. Yeah.
And now find maximum minimum of this. So f dash t will be equal to 4 into 1 plus t square minus 4t into 2t by 1 plus t square whole square, right?
Yeah.
You get
Yeah.
4 plus 4t square minus 8t square. So 4 minus 4t square by 1 plus t square whole square. So basically t can be plus or minus 1, right? Right.
Yeah.
But t cannot be 1 and t cannot be minus 1 also, right?
Hmm.
Because t is greater than equal to 2, right?
Yeah. Yeah.
2. Yeah.
Okay. So that means then that the function is not approaching any maxima minima here. Like the no maxima minima is coming, right? F dash x is not becoming 0, no? F dash x is positive.
Yeah.
Yeah. Yeah.
For t, oh no, f dash x is negative actually. T greater than 2, f dash x is negative. F dash t less than 0, right?
Huh.
So it is decreasing, right? So let's check the value at t is equal to 2, right? If t is equal to 2, so function is decreasing, no, for all t greater than 2, right?
Mm-hmm.
Yeah.
Are you understanding? Because f dash t is negative, right?
Negative. Yeah. Yeah.
F dash t would have been 0 at plus minus 1, but right now we are not going to search in the region at t is equal to plus minus 1, right? Because t was x plus 1 by x, and for positive x it is always greater than equal to 2, right?
Yeah. Yeah.
It will be equal to 2 when x is equal to 1. For any other positive x, it is greater than 2, right?
Hmm.
Yeah. Yeah.
So
Yeah.
we should check our function f dash t where t greater than 2. In that region, we have the numerator always negative, right?
Huh. Huh.
So as you give inputs, the value of the function is decreasing because slope is negative, right?
Mm-hmm.
So at t is equal to 2, what is the value? At t is equal to 2, value of f of t, f of x, right, is becoming basically 4 into 2 by 1 plus 4, right?
1 plus 4. Yeah.
8 by 5, right?
Yeah.
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 8 by 5 should be maximum value then,
Maximum.
no?
Yeah.
Right? And as you go further and further away, t becomes say 100, you will get smaller and smaller values.
Smaller approaching 0. Yeah.
And t tends to infinity, it will approach 0, no?
Yeah. Yeah.
T
Mm-hmm.
tends to
Yeah.
infinity, it will approach 0, f of t, right?
Yeah.
So 0 to 8 by 5,
Hmm.
right? Like
Yeah.
this. And
Yeah.
notice that 8 by 5 is still less than 2,
Yeah.
which we had earlier gotten by AMGM, right?
Right. Yeah. Yeah.
So 0 to 8 by 5, that should be the answer. Okay.
Yeah.
X is equal to 0. What is the value coming? Just check once. Fx is equal to 0 at x is equal to 0, right?
Yeah.
So 0
Yeah.
is included.
Yeah.
Okay.
Okay. Yeah. Yeah.
Right? So that is the solution. So you have to think of like multiple things. You can use calculus to find maxima minima. You can also use AMGM. All of these things and ideas are useful while calculating range. Okay.
Yeah. Yeah.
So let's move on to 27. 27 is looking complicated. So let's see what it is. Fx is equal to fractional part of x plus fractional part of x plus GIF of x by 1 plus x square, right?
Yeah.
And whole thing is fractional part plus fractional part of x plus GIF of x by 1 plus 2x square, and so on till fractional part of x plus GIF of x by 1 plus 99x square, right? This is your function, and you are supposed to find GIF of f of root 3, right?
Yeah.
Yeah, yeah.
Okay. It looks complicated, but maybe there is a nice solution. Let's think about it. Actually, this is a trick question. So you think about it, it's actually a very easy question. Think about each of these terms. What will the value of each of these terms be?
All of them come out to be fractional part of x.
What?
All of them come out to be fractional part of x.
Yeah, because these are integers.
Yeah.
Right. Yeah. Mm-hmm.
Integer plus x fractional part will be always fractional part of x only, no?
Yeah. Yeah.
So therefore, there are actually 99 such terms here. So it will be just fx is simply 100 times fractional part of x.
Fractional part of
Yeah.
x.
So then it is super easy. Find f of root 3, right? So f of root 3 is equal to 100 times fractional part of root 3, and then you have to do GIF also.
Yeah. Yeah.
So okay. So root 3 fractional part will be what? 0.732, right? Something like this.
Correct, yeah.
Multiply by 100 makes it 73.2.
73.
GIF will be 73,
Yeah.
right?
Yeah.
Yeah.
So that is the answer. There's no issue here. It's just that you have to realize that this big looking thing is actually simply fractional part of x.
Yeah.
You can ignore these parts, right?
Yeah.
Okay. Question number 28 then. Question 28 is what? Let a function be defined. Okay. No. Let number of functions. Fine. So let A be a set 1, 2, 3, 4, and you have to find number of functions from A to A, f from A to A, which satisfy f of x is equal to x for all x belonging to A, right? Number of functions which satisfy this equation. Correct. So
Yeah.
okay. Okay. So A to A, you have A 1, 2, 3, 4. and 1, 2, 3, 4, right? And f is a relation between a to a. So first, if there, how many total functions are there? Can you find that out? Total number of functions without any restrictions. Total number of functions. So for each output value here, you could have connections from anyone, right? So one could have a connection from 1 or 2 or 3 or 4, right?
Yeah, yeah.
And 2 could have a connection similarly from any 4, any of them, right?
Yeah.
So you could also have into functions, so you have to be careful about those. Let's count the number of let me think once. I think it will be 4 power 4. You have to think of y though. So total number of functions is 4 power 4, I think, because each of the 1, 2, 3, 4 could take 4 possible inputs. 4 possible inputs. Or think in the opposite way. You have to cover all of these, right? All of these have to have some outputs, right?
Yeah.
So first one can have 4 outputs. It can have 4 outputs. It can have 4 outputs. It can have 4 outputs.
Yeah.
So total number of functions is 4 power 4. Because this set is complete, no? You have to complete this set. This set you are doubtful about, right?
Yeah. Yeah.
Because you could have 3 only. It could be an into function, right?
Yeah.
But
Yeah.
from this side, there is no doubt, right? You have to have like, you have to cover all of the elements in the domain set, right?
Yeah.
So there are 4 options for each element, right?
Yeah. Yeah.
Not in one function. This diagram is just showing how many different places one can go, right? In one function, one will have only one value, right?
Yeah.
Yeah.
Correct.
Yeah.
So 4 power 4 is 256 is total number of functions. You have to now think about how many of them are such that this condition is true, right? So this condition means actually that fx is equal to f inverse of x, no? Because you can take
Yeah.
f inverse on both sides. Fx is equal to f inverse of x is coming. The function is such that it is equal to its inverse.
Yeah. Yeah.
Right? Or you can also think of it as 2 times you have to apply the function and then you'll get the same x, right?
Yeah.
So
Yeah.
okay, so let's think. So if it is an identity function, right? It could be identity function, right? Fx is equal to 1, right? That is a possible function, no? or fx is equal to 2, right?
Yeah.
So, okay, then it doesn't satisfy this, right? No, it doesn't satisfy this for all x, right? Because for x is equal to 2, it will not satisfy, no? If
Yeah. Yeah.
fx is equal to 1 is my identity function, then left hand side will be f of 1 and 1, and that will be 2 for x is equal to 2, no?
Yeah. Yeah.
So identity function doesn't satisfy. But what about this function fx is equal to x, right? That function will obviously satisfy,
Right. Yeah.
right? So that is one function like that, right? One function which is fx is equal to x,
X.
right? Now you have to find out other functions which will also satisfy this, right?
Yeah.
So fx is equal to x is one function. What other functions will satisfy this? So f of x is equal to x. Is there any other function? What is the other function? I cannot think of any one function which will satisfy this for all x. Wait. Okay, so you can construct functions like 1 is going to 2 and 2 is going to 1, right? And 3 is going to say 4 and 4 is going to 3. If you think of this function for x is equal to 1, what happens? F of 1 is 2 and f of 2 is 1, right?
Yeah.
So it is satisfying, right? X is equal to 2, f of 2 is 1 and f of 1 is 2. Oh yeah. This function satisfies, no? This drawing that I've drawn.
Yeah.
You understand?
Yeah. Yeah.
This is a type of function that will satisfy this relation, right?
Mm.
Is everyone understanding what I'm doing?
Yeah. It has
You
to
are
be.
you are making it such that f of 1 is 2, then f of 2 has to be 1, right?
1. Yeah.
Yeah.
Then f of 1 could have been 3 and you could have made a pair of 1 3 and 3 1 and 2 4 and 2 4 2, right?
Yeah.
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 Right. So how many such functions are there? You have to
Functions,
count.
yeah. Okay.
How many such things are there, right? So okay. So you are doing pairs of 1 2 and 3 4. You could do pair of 1 3, 2 4, 1 4, 2 3, right? Correct?
Yeah. Yeah.
These
Yeah.
type of pairs are there. Now any other pair 2 3. No, 2 3 is already coming. 2 3, 2 4 is already there. So these are all there. These three are there for sure. Three functions like this, right?
Yeah. Yeah.
What else? What else can we do? If okay, we can also make functions like, let's think about this one. So 1 2 1 2 3 4, and you have 1 2 3 4. What if we do 1 2 2 1 and then we do f of 3 is 3, f of 4 is 4? Is that working? Just check. F of this one, this part works. F of 3 is 3, f of 3 is 3, f of 4 is, oh, okay, it works, right?
Yeah.
It works. For, are you understanding why it works? This
Sir,
function.
can you explain it again? Like the f of 3 is.
I'm saying f of 3 is, suppose this is my function. Can you see the function?
Yeah. Yeah.
Here, f of 1 is 2, f of 2 is 1, f of 3 is 3, f of 4 is 4.
Yeah.
Then see whether this works for x 1 2 3 4, right? We know that it will work for 1 and 2, right? Just like it worked
Yeah,
here.
it will.
Yeah.
So let's check for f of x is equal to 3. F of 3 will be 3, f of 3 will be 3, right?
Yeah,
And x is 3.
works, yeah.
Oh, okay. Yeah.
Because this function works, no? F of x is x always works.
Yeah,
Right. Yeah.
yeah.
This was the function where 1 was 1, 2 was 2, 3 was 3, 4 was 4, right?
Yeah.
Right? So this type of pairing will work, right? Where
Yeah.
one of them is in a pair and two others are
Others
constant,
are
right?
constant,
Right, yeah.
You can't do only one of them is this, because then 3 you cannot make pairs, right?
Yeah.
You understand? You cannot have. Can you have that 1, 2, 3? 1 is 2, 2 is 3, 3 is 1. Can you do that? Wait, let me think. You have 1 is 2, 2 is 3, 3 is 1. Does that work? No, I don't think so.
I don't
1
think
is 2, 2 is 1.
Then
No,
you
it
get
doesn't
f
work.
of
Doesn't
f of
work,
1
yeah.
as 3 or something.
It doesn't work.
Yeah.
So this will not work. So this works. So now we have to count how many places this can happen, right? So you can make a pair of 1 and 2 and constant functions on 3 and 4.
Yeah.
You can break 1, 3 and 2 and 4 are constant.
Constant.
1, 4 and 2 and 4 are constant. 2 and 3 are constant. You can make 2, 3,
2, 3,
2, 4
2, 4
and 3, 4, right?
Yeah.
Correct? And the
Yeah.
remaining 2 are constant, right?
Yeah.
Right, yeah.
So 1, 2, 3, 4, 6 functions here, 3 functions here, 1 constant, 10 functions we have got.
Yeah.
Okay. 10 functions so far we have gotten. Now what? Still the
have
answer
1,
is
2,
what?
2, 1, 3, 4 and 4, 3 also.
1, 2,
2,
2,
1,
1.
3, 4 and 4, 3 like all.
What are you saying? What? Explain.
So you can have 1 to 2,
Then
1.
2 to 1. Okay, these are pairs. 1 to
Yeah,
2.
and then,
Oh no, 1 to 2 and
yeah,
2
like
to
that.
1. Yeah, then
And then 3 to 4, 4 to 3 like that.
that we have already done. No, this was this.
Okay, yeah.
That was already the first case, right?
Yeah.
2 pairs we have already done all cases.
Yeah.
We have also done 1 to 3, 2 to 4, 1 to 4, 2 to 3, right?
Yeah.
So nothing is left in that case, I think. 2 to nothing is left. No, if we are missing something there, then it could be possible. So let's just check the answer once. I'm getting 10 functions right now. Answer is how much? Yeah, answer is 13 functions. So we are missing 3 functions.
Wait, so there are 9 functions here, right?
Where
Like you wrote 9 functions, but where's the 10th one? Which one
fx is equal to x.
Oh, like that. Okay, yeah, direct, yeah.
All 4
All 4
all
is
4, yeah.
constant. Yeah.
all 4 are constant. That is the 9th function. But
Yeah,
I
yeah.
think we are missing something here. Maybe 3 more might be possible. Let's think. 1, 2, 2, 1 we have done. 3, 4, 4, 3 we have done. I feel like I'm not missing anything. I mean, if you change the values, 1, 3 pairs, 1, 4 pairs. Is there any other type of function that is set aside this? We have taken pairs of these two and two like this. Can we do something else? Feels unlikely. Okay, what about, is there some type of identity function that will satisfy? 3, 4. Wait 1 second. Let's think about 1, 2, 3, 4. 1, 2, 3, 4. And let's say 1, 2 is 1 and 3, 4 is 2, then no, 1 is 2. One. What about 2, 3, 4? Feels like we are not
Should
getting.
it come as six cases in the first one that we checked?
First one is giving 3 cases, no?
Yeah, but should it be 6?
That is what I am also thinking, but
Because if
it
it's
feels like
6, then
if it is 6, then it will be 13 answer. But right now it feels like, because first one is 1 goes to 2, 2 goes to 1, 3 goes to 4, 4 goes to 3. And then 1 goes to 3 and 3 goes to 1. And 2 and 4 are making pairs, right?
Maybe we can do the reverse also. So 3 goes to 4, then
Oh, that is already
like
done. No?
that. Oh
3
yeah,
goes to
it's
4, so it's already covered. You cannot do, there's no reverse. I mean, already is done, no? We are
yeah.
getting what grouping of 4, but this doesn't work. This is 6, but this grouping you have to divide by the actual number of things are 3 only. Okay, right now there is a slight doubt. I am getting 10 functions, answer is saying 13, so we'll have to think about it. So just mark it. I'm not getting any other functions right now. Mark it, think about it. If you can find some functions, then great. Let's go to 29. But did you understand what we are supposed to do in the
Yeah.
previous
Yeah,
one?
yeah.
It is just counting of the functions from A to A where it satisfies that condition. So you have to think creatively about how you can construct a function that satisfies that, right?
Yeah.
Yeah.
Once you solve some problems like that, then you'll get the hang of it. So just think about that a little more later. 29. Let's look at 29. Fx is defined on R to R. Fx is equal to m minus x for x is less than equal to 1 and 2mx plus 1 for x is greater than 1. He's saying if the function is onto on R, is onto on R, then range of m. Then range of m is what? Okay. Function is said to be onto. That means range of this function is supposed to be real numbers, right?
Yeah.
Yeah.
Okay. So what will we do to make range of m real numbers, right? Correct. So okay, function is onto on R. So my m minus x will go till minus infinity, no? Right? Because x can become minus infinity here, right?
Yeah.
Is there any restriction? Yeah, there is nothing. M is a constant,
Yeah, it can go to.
right?
Yeah.
So what about this? Okay, this also seems like it can go to R, no? Okay, so make sure that m is not 0, right? Right? If m is 0, then this function is constant, right? Second part. You understand? If m is 0, the second part becomes 1, right?
Yeah.
Yeah.
Then it
Yeah.
cannot be onto.
Yeah. Yeah.
But if m is not 0 and oh wait, we have to make m positive, right?
Positive. Yeah.
M should be positive also, because if m is negative here, then it will not go up till infinity, no? Because x greater than 1, right? You understand what I'm saying? Fx has to reach plus infinity also, and fx
Yeah,
should
yeah.
reach minus
Yeah, yeah,
infinity
something.
also, right?
Mhm, yeah.
So how will it reach plus infinity here? First of all, m should be positive and m should not be 0,
Hmm.
right?
Mhm,
Then after that, for large values of x, it will reach whatever number you want,
Yeah,
yeah,
right?
yeah.
yeah.
And in this case, there is no restriction. M can be whatever, and x will go up to minus infinity, no?
Yeah, yeah.
As long as m is a constant, x can go down to minus infinity, right?
Right, yeah.
Mhm.
So what I'm getting is m should be greater than 0. That's it, right?
Yeah, yeah.
No other restriction. So D answer, right?
Mm,
D should be the answer. He's saying B for some reason. Why B? B seems wrong though, because if m is negative, B is saying -2 to 0, no?
Mhm,
And if m is -1, if m is -1, then you have m minus x for x less than 1, and -2x plus 1 for x greater than 1, right?
yeah.
For x greater than 1, this is 1 minus 2x. So this function is always decreasing, right? As x
Mhm,
increases, right?
right, yeah.
So this is
yeah.
never becoming, oh, because of this, it is becoming infinite. Oh, okay, okay. You understand for this part. X is less than 1 here. No, that was the mistake. X is less than or equal to 1. No, so x can be minus
Yeah,
infinity,
yes.
then it will go to plus infinity,
Yeah, yeah.
Oh,
right?
oh,
It is
yeah, yeah.
opposite. And
Uh,
here,
uh,
okay, okay. So our thing is a little different. X is positive, you have to go to minus infinity, right? So x should be negative then, right?
yeah.
M should be negative.
M should be.
Negative.
Mhm, M should be negative, yeah.
Because x is positive, you are not getting to minus infinity. You are not getting to minus infinity here. You're getting to infinity here, right?
Yeah,
Right, yeah.
yeah.
And you're getting to minus infinity here, right?
Yeah,
So
yeah.
m should be negative. Okay, fine then. M should be negative. M cannot be 0. That is true,
Not be 0. So,
right?
from
But why
D would
-2? Why -2 though? Uh, if m is -2, -2, there doesn't seem any reason. Fx is equal to m minus x 2mx plus 1 and equal to 1. X is greater than 1. Why 4 minus x
from
less?
-2,
Let's check.
when we put -2 and x
Uh,
as 1 in both, we're getting the same values. Like,
-2 as m.
yeah,
-2 minus x and minus 4x plus 1.
and if you're putting 1, we are getting -3 in both.
This part will rise up to plus infinity if x is minus infinity,
Yeah,
Yeah, yeah.
and this part will go down to minus infinity. This is fine, but why not -3? -3 should also work, no? I don't see any reason for why not -3, right?
there might be a like gap coming in.
Uh,
Because when we are putting x as 1 in this, we're getting common value as -3, right?
okay,
For
at
both.
x is equal to 1, you have to check.
Yeah, we're getting common as -3. Because I think it has to
M
be
minus x,
continuous.
it has to be continuous. M
Yeah,
minus x
there
is
can't
equal
be a
to,
gap.
you have to check this solution at x is equal to 1, right?
Yeah,
Hmm.
So at x is equal to 1, since the function is changing, you cannot skip values, right?
yeah,
It cannot be like this. It has
yeah,
to
it can't be
touch,
like that.
right? So at x is equal to 1, if you put, you'll get, I think, 2 or something. So you're getting, okay, you're getting -2, right?
Yeah, yeah.
You're getting m is equal to -2, so that you are ensuring that these two lines are intersecting. You have to
Intersecting,
intersect
yeah.
the lines. You cannot have two disconnected lines.
Hmm.
Yeah.
Okay, so that is why -2 is at the boundary range, and you have to get negative values. And if you have -3, I'm sure the lines will not intersect.
Hmm.
Okay,
Yeah.
so that is the reason. So okay, now we understand. So you don't just have to make it -infinity and +infinity. You also have to check whether it doesn't skip anything. No, it has to cover everything,
Yeah.
Yeah, yeah.
right? It has to intersect at least
Hmm.
at the point where the function changes.
Yeah. Yeah.
Okay. Try more questions. Try this exercise. Okay. More and
Yeah.
more questions that you do, the better it will be. So we will start the next chapter soon, but maybe one more class we'll do of questions. So please attempt as many questions as you can in the next week so that we can have a productive discussion. Because once we go ahead, like you might not get enough time to practice more here, right? So try out as many questions as you can. Okay. That's all for now. Let me know if you have doubts and all what is happening.
Yeah.
Yeah.
Okay. Bye.
Bye, sir.
Bye, sir.
Thank you, sir.
Mm, bye.